Hello everyone, my name is Zhaoye Lyu. This is a schematic of the all-terrain tracked vehicle which I designed. And on this car, we will use batteries, provide power to two DC motors, and make wire or cold checks move. And the three ultrasonic sensors is used for avoiding collision. Light sensor is used to record the number of squares, and the potentiometer is used to judge direction. The car also has a bumper to immediately stop the vehicle if a collision is detected, and the two LED headlights illuminate the ahead scene. First of all, I will give a view of overall Tinkercad circuit. And lab view. Now, I will demonstrate in detail the functions and program code that the car achieves. This is all parts of my car on original. You can see there are two 9-volt batteries, provide power through the L293D shape to the DC motors. And these two DC motors can provide power to the wire, and the car can move. And there has three ultrasonic sensors. This is front sensor, this is left, and this is right. So let's run. These three sensors can help identify obstacle ahead and automatic obstacle avoiding car. You can see each sensor has a recognizable distance. If the car on the road to progress depends on the ultrasonic sense to recognize obstacle ahead, will automatically to prevent the car collision. This two potentiometer is to control these two model, so we need to some change. You can see the speed is to change. And it helps cars to turn left or turn right. So for example, if the car left is too close object and right is no object, so according to the front sensor, he will turn hard right. And this is the light sensor. If this is not a squirrel, the light level is too high. If it's a squirrel in front of the light is low. So if there have squirrel in front of light, so light is become low. And if the squirrel is go out, is be high. So the squirrel count is become the 1. And if one times gap, squirrel come and squirrel go, squirrel leave, this count is become 2. And the third potentiometer is help us to do the direction of the car. So you can see this is his X value and Y value. When I change the X value and Y value, also need to change. Yeah, you can see. And this push button is used to bumper. If the car is detected the collision, so this push button will be click. Yeah, and you can see these two models have their speed, and when the car has been pushed, you can see the model speed is become the 0. Yeah, the two models is also the 0. So it means if collision is detected, the car will immediately stop. And this two LED is illuminated ahead scene. So this is my code. This is something you need to define an int. And then there is my loop from about 3 cents, and this is model 1, this is model 2, and this is potential 1 and 2, and this is light sensor, and this is the LED light, and this is secure count. Yeah, and this is auto value to the level view. Now we comes to level view. This is my 11th input from the original, and this one is error to check if his character is equal 11 letters. If no, he is warning. Yeah, and this is 3 ultrasonic sensors, and this is heading sensors. This all ultrasonic sensor and heading sensor is the fuzzy control. And I have set up this fuzzy control about 3 sensors and heading sensors and his steering. And this is my fuzzy control rules. 3 multiply 3 multiply 3, so it is 27 rules in there. And this is the light levels value, out value, and this is a driven pattern. If this is true, it means automatic. So this from original automatic left speed and right speed will input this case, and output from this case to this output string. If it is false, means it is driver by hand, so I input this to speed. We can control the manual speed and output in the output string. And this is square count level view program. This is means 100 of square count. This is decade, and this is unit, and 100 multiply 100 plus decade provide 10, and plus unit is the finally count. And this is bumper. Yeah, is 66 because 65 is means A and 66 is means B. If you make a conclusion is output is B, so it's equal 66, the bumper is warning. And another thing I have to say is I need to put fuzzy and this speed together, then output, because the fuzzy can help us to correct the speed. Yeah, and the fuzzy is according the ultrasonic and heading to help the located direction. And this is level field in front. And I copy this original old value, this one, copy to paste the level field, run. We can see there's squirrel count and different sonic value and this speed. It is same with the original old value. And this is the driven pattern. If you want to driven by hand, you can click there and you can set up your left speed and your right speed. And is error checking. If you not 11 calculate, you can see the error checking is right, so you need to add. If you added B, means the bumper will be meta occlusion, so the bumper will light. This is PID control. Because every letter has his own range, so is speed. Use the letter to mean speed. It has an arrow, so PID control can help us to make speed steady and correctly. This is serial communication. It mentally plays a role of data transmission between host and peripheral as well as host, and is convenient to the communication.